Good morning. Welcome to the lecture 12 of this ongoing course on architectural graphics or engineering graphics, and we are discussing about orthographic projection here. So, we have already understood the basic fundamentals related to orthographic projections, and today we are going to discuss the difference between first quadrant and third quadrant. So, as I had explained to you with the help of this quadrant system, just to quickly revise the fundamentals which we had visited yesterday, the plane which is vertical is a vertical plane, and before you confuse, these planes are the screens onto which the views will be projected. So, these are not actually just any plane, these are the projection screens where the object will be somewhere in either of the quadrants, and then we will see how the projections, the views are seen onto these screens. So, the one which is vertical is a vertical plane or a frontal plane. So, always we have the front view being seen perpendicular to the frontal plane. So, we have the object kept here maybe, and we are seeing perpendicular to the frontal plane. So, this is the frontal plane, vertical plane, this is the horizontal plane, and then these are the extensions beyond it. So, horizontal plane going beyond the vertical plane and vertical plane going below the horizontal plane creates three more quadrants like this. So, this is first, second, third and fourth. What I explained is to draw it on sheet, we assume that this quadrant system, these planes are folded like this. So, this is how the sheet would look like. This is for the first quadrant. Now, what is it for the third quadrant? So, let us understand that difference. If we are assuming an object to be kept in the first quadrant, any object, for example, this sphere, we assume that this sphere will be kept somewhere in the front, in the first quadrant, and it will be projected onto these screens. While in a third quadrant, what we would assume is that the object is kept somewhere here. Okay. Whether the object is kept here or here, the planes would still fold like this. So, what will happen if I had the object placed in the third quadrant, which was at the back of it? How would I see? Because I am anyways, and then we are always seeing it from this side. Our viewing will always be perpendicular to this front plane in the first quadrant. So, when we are seeing it in the third quadrant, how do we draw the front view? How do we draw the top view? And top view we are seeing from top. So, it could be here or it could be here. So, this is how we are going to be seeing the object from the top. So, let us understand this difference between the first quadrant and third quadrant. In first quadrant, we have the vertical plane in top and horizontal plane in the bottom. The reference being this reference line, which is xy, while what has happened in third quadrant, just see, we actually had the horizontal plane, this is the horizontal plane. So, the horizontal plane is coming to the top, because if the object, say the object is here and I keep this quadrant here. So, if the object is here and we are seeing from the top, the view is actually being achieved here, and the front view, since we were seeing it from this side, the front view is being projected onto this vertical plane which is extended beyond. So, when we fold it, we actually have the horizontal plane going up and the vertical plane coming down below the xy line, the reference line. So, what we have is, we have a reversed view from first quadrant. So, in first quadrant, we have the front view on top and top view plan in the bottom, while in the third quadrant, we have the top view in top, the plan above and the elevation in the bottom. There isn't any difference. Another thing that we have to keep in mind is that the position of the object will have to remain identical if we want to either see it in first quadrant or in the third quadrant. So, the distances that it has from the front plane and the horizontal plane will have to be maintained as the same in the third quadrant. So, whatever distance it had in the first quadrant will be the same distance that we will maintain in the third quadrant. And so, the view will remain exactly the same. Suppose this was the cone. So, if we were seeing this cone from the front, it would appear to be a triangle, and if we were seeing it in the third quadrant like this, we are still seeing it from here, and it would still appear as a triangle in the front elevation. The only difference being that the front elevation in case of third quadrant is drawn below the reference line, while in case of first quadrant it is drawn in the front elevation which is above the reference line. That is how this difference is. Another difference that we have is when we draw the views. So, if we assume that the object is kept here and we are seeing it from the top. Now, there is nothing between the viewer from where we are viewing it and the object. The plane is actually beneath the object. So, the horizontal plane is beneath the object and the vertical plane or the front plane is at the back of the object. So, in this case, in case of first quadrant, we are assuming that this plane, the vertical plane and horizontal plane are opaque planes. So, the viewer actually is also casting the shadow. So, the shadow from the straight light rays are being projected onto the screen, and this is what we see in the front plane and the horizontal plane, the frontal plane and the horizontal plane. So, assuming that this is actually an opaque projection screen, it is a screen, while if you assume that this is how the object is going to be, and if we really had a screen like this where it is an opaque screen, if I want to try to see it from top, I won't be able to see anything. If I try to see it from the front, because the front is this side, I won't be able to see anything. So, in the third quadrant, when we project, we assume that the plane, the horizontal plane is transparent and the front plane is also transparent. In this case, the projection plane is between the viewer and the object, between the viewer and the object. So, it has to be transparent. That is how we will see the object. So, that is the difference between the first quadrant and second quadrant, and all other things will more or less they will remain the same. The projection lines will be parallel to each other, they will meet each other. So, if we have any object, we should be measuring one dimension only once. That is how it is. So, for example, if this is a cone, what all dimensions do you require to depict a cone? That okay, this is a cone. We need the height of the cone, we need the radius of the base, and that is all. Now, if I were to draw it in any projection system, by the way, the third quadrant projection system is used in United States and several other countries, while for us in India, as per Bureau of Indian Standards, we always go for a first quadrant projection. So, we will be henceforth we will be discussing about the projections in first quadrant only. Now, I was explaining about measuring one dimension only once. So, if I have to draw this cone, from the top what would I see? We will see a circle, and in that case if it is flat, what would we see? We would see a circle and the actual radius of that circle. Why? Because this surface, which is the base, is kept parallel to the horizontal plane. So, any surface which when kept parallel to a projection plane will appear to be in its true dimension. That is the fundamental basic, because we have these light rays which are perpendicular. So, the distance between the light rays is exactly the same as the dimension of the object. So, we see the circle, from here we will get the radius, and if we draw it in the front view, we will get a triangle where we would see the height and also the diameter the radius of the circle. So, what we actually have to do is dimension this object only once, the height in the elevation and the base, radius for the base circle or diameter for the base circle in the plan. That is what we are going to do. Suppose it was a cube, for example, or maybe it was a complicated cone. Suppose we have a pentagonal pyramid. So, what we have is we have a pentagon in base and we have a cone like structure. So, all of it is merging in the vertex on top. So, in the plan if we draw, we would see a pentagon coming, the dimensions of it will be seen, and in the front elevation we would see the height, which is what is required. Now, just imagine that the cone is not placed like this. If the cone was placed like this, then in that case what would we see? We would actually not be seeing the pentagon in its true shape here, because it is not perpendicular to this. If it was perpendicular, the apex of this cone will not be resting on ground. The moment it rests in the ground, we will see a deformed pentagon both in plan and in elevation. So, in that case, we will either have to assume that the cone was first placed like this and then it moves like this, so that we know the true dimension, or else we can draw the projection of this particular base pentagon on another plane which is kept parallel to the base, which is assumed to be parallel to the base. So, that is another requirement or another feature which we have to keep in mind. Anything which is parallel to the plane will appear to be in its true shape, and that is the reason why if we need to show the true shape of the object, true dimensions of the object, we have to project it onto a plane which is parallel to it. So, besides these defined planes, which is the vertical plane and the horizontal plane, and we also have the side vertical planes as well, which are like perpendicular here and they will be opened up like flaps. We also have auxiliary planes. These auxiliary planes can be placed anywhere as per our convenience, and they are required to see the true shape of the solid. So, we also have, say, an octagonal pyramid here. So, we might be keeping it like this, or it might also be kept like this, which is absolutely from nowhere can we really see that what is the true shape of this octagon. To determine this, we will have to assume the object to be in different positions first and then try to see what its final projection looks like. Or suppose we have a section. So, what would be the true shape of the section will actually be determined only if we have a plane parallel to this section surface. So, that is where the auxiliary planes come into picture. However, all this is going to come much later into our into the syllabus, and we would be starting with the projections of very simple objects, starting with points, projection of points first. But here what we have to understand is the difference between the first quadrant and third quadrant, and we are going to restrict ourselves to all the projections in the first quadrant only. So, that is all in the lecture today. From the next lecture onwards, we would start to draw the projections of different objects, starting with point to line and then planes, and then moving on to solids and then section of solids. So, before I close my lecture today, let us see a glimpse of what would the object, if projected with a light source, look like if it is a light source which emits only parallel rays. So, let us see a quick demo of that so that you are very clear about how the projections are really cast. So, to explain this concept of orthographic projection in first quadrant, just assume that this is the vertical plane where we are seeing this light coming from. So, this is the vertical plane and this is the horizontal plane where this makes the first quadrant, and that is a side plane. So just assume that we have a point, for example, just a, or maybe a line to start with. So if I keep this pencil like this in the center of this, what do we see? In the front view, we will only see a straight line, while in the plan, we would only see a single point because we will be seeing it from the top. Now replace this with a, say, plane. For example, this is a plane. Assume it to have no thickness. If I keep it right straight in front of this, so this plane is actually perpendicular to the horizontal plane and parallel to the vertical plane. What you see in front is actually a rectangle. But in horizontal plane, we would only be seeing a line. So what we get out of this is anything which, when kept perpendicular to a plane, will be seen only as a, that is in case of a point or a line, that it will only be seen as a straight line. However, when we put it parallel, we will be seeing the true dimension of it. So if you look at it like this, where it is perpendicular to the VP, we will only be seeing a line in VP, vertical plane, while in the horizontal plane, we would see a rectangle, this entire true shape of the rectangle, while in the vertical plane, it's only the one dimension of this rectangle that we are seeing. Let us see how the solids look like. So this is the cube, the example of cube that I have been explaining to you. So if I hold this cube like this, such that its faces are either parallel or perpendicular to these projection planes, what do we see? We see a square in the front view and a square in the top view, the plan. Now I am rotating it at 45 degrees. What do you see in the front view? We see a rectangle, but it is actually not a rectangle, it is a deformed square. So we are actually seeing these two squares here, and when we see, we will be seeing one edge which appears as a line. So we will be seeing a rectangle here, a smaller rectangle, another smaller rectangle, and in all we will be seeing one single rectangle with a line in the center. If I keep the same cube on one of its edges like this, what do we see? We see a very deformed shape. It is not rectangle, it is not square, it is a combination of some rhombuses. So that is what we are seeing, but none of it is in actual true size, its actual true dimension. Again, if I put a cone, this is a pentagonal cone, what do you see? You see a triangle. Now this triangle does not give us a clear idea about what is the size of the pentagon, the base, but it gives us a very clear idea about what the height of this cone is. While if I keep it like this, then you can very clearly see that it is a pentagon. And then we will be seeing these lines, these edges merging to the apex. So we will be seeing a pentagon and some lines merging into a point. So what I wanted to explain to you was that in the first quadrant and in orthographic projections, we will always assume the light to be coming, the light rays, the projection rays to be coming parallel to each other and perpendicular to this plane. We cannot be assuming them coming parallel or at an angle to this vertical plane and horizontal plane, otherwise the views would become deformed. So this was all about orthographic projection here in this lecture today. So all that we were understanding about first quadrant projection is what we are seeing here. This is the vertical plane that we assume, this is the horizontal plane, and this is the side plane, and we were assuming the objects to be kept in the first quadrant like this. So we would either have the projection coming as elevation or plan or the side view. I hope with the help of this you have fairly understood the difference between the first quadrant and third quadrant, and also the fundamentals of first quadrant. So henceforth we will only be restricting our discussions and our drawings to first quadrant drawings, because this is what is prevalent in India. and from next class onwards we will be discussing about the projection of points, lines, planes and solids. So thank you for being with me today and see you in the next class tomorrow. Thank you.